In section 3.2, we're going to look a little bit closer at polynomial functions. So the definition of a polynomial is it's any function of the form f of x equals a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus a sub n minus 2 times x to the n minus 2 and all the way down to a sub 1x, a sub 0. So the idea here is that you have a whole bunch of real numbers, a naught through a n, and then you have those things multiplied by powers of x. So it's really just sums of powers of x where you allow the coefficients to be real numbers. And the a sub n is called the leading coefficient, and the a sub 0 is called the constant term. Right, because that's like a sub 0 is a sub 0 times x to the 0, or 1. Now, here the key is that for something to be a polynomial is basically that the powers of x cannot be negative and they can't be ratios. So examples of things that are polynomials would be like 1, let's see, f of x equals 3x squared plus 2. That's a polynomial where a sub 2 is 3, a sub 1 is 0 because there's no x term, and then a sub 0 is 2. Okay? And so here we say that the degree is 2, and the leading term is 3x squared. Leading term is 3x squared, and the leading coefficient is 3. So a sub n is called the leading coefficient, and a sub n times x to the n is the leading term here. Okay. Now example 2 would be something maybe like g of x equals pi times x to the 4th plus the square root of 2 times x plus 7. Now in this case, a sub 2 or a sub 4 equals pi, which is a real number. A sub 3, a sub 2 are both 0 because there's no x cubed term or x squared term here. A sub 1 is the square root of 2, which again is a real number. And finally, a sub 0, the constant term, is 7. Okay? So here the important thing is that the powers of x are integers, positive integers, and the coefficients are real numbers. So this is also a polynomial. We say it has degree 4 because the leading term is pi x to the 4th. So the leading term is pi x to the 4th, and the leading coefficient is pi. Okay, let me just give you a few examples of things that are not polynomials, because this is probably just as informative. So an example of something that's not a polynomial would be like h of x equals 3x squared plus 2 plus x to the minus 1. And here the problem is that you have a negative power of x. So that's the problem there. And then 2, second example might be something like k of x is, I don't know, x to the 5th plus 2x plus the square root of x. And here the problem is that the square root of x is actually the same as x to the 1/2. So now here the problem is that you have a fractional exponent. So both of those are the reasons why these can't be polynomials. Okay.